Imagine buying this incredibly complex, expensive machine, and, well, instead of spending hours tuning it, the machine just physically learns how to use itself for you.
Right. Which sounds like science fiction, but it is actually happening.
Exactly. So today's deep dive mission is exploring a stack of community hardware hacking forums, developer logs, and, some brand new AI research focused on autonomous 3D printing. We are basically looking at how static, dumb hardware is being transformed into these self-configuring, cyber-physical robotic fleets.
Yeah. But to actually get there, you really have to bypass the manufacturers first, because they usually lock these machines down with incredibly rigid static firmware.
Right.
You can't just plug an AI in. You really have to physically perform a brain transplant on the machine.
I was reading through the community guides on this, specifically this process they call de-elegooing.
Oh, yeah, I saw that.
Yeah, for the Neptune 4 Max printer. And it just sounds intense. Like, why do users literally have to rip out the original memory chip and flash a blank slate just to get the AI working?
Well, because, that original memory chip is basically a walled garden.
Ah, right.
Yeah, the AI needs a completely open environment to operate. So users are physically opening the bottom plate. They are extracting the embedded eMMC storage module and then using an adapter to install a vanilla Linux operating system.
Okay, so it is exactly like jailbreaking a locked-down smartphone to install an open-source OS.
That is a perfect analogy, yeah.
So you get root access to the actual hardware engine, not just the apps the manufacturer allows you to use.
Exactly, and that root access is critical because of how the new firmware operates. It is called Clipper.
Okay, Clipper.
Yeah, and traditional 3D printer firmware, it forces you to recompile the entire code base just to change a single setting. But Clipper completely shifts that paradigm.
How so?
It uses a simple, readable plaintext file, just a printer configuration file, to define literally everything about the hardware.
Oh, wow. And I guess since it is just a text file, an AI can read it.
Right.
So using Anthropic's Model Context Protocol, the AI can securely look at that configuration, understand the setup, and just rewrite it on the fly.
Yeah, it issues real-time commands using Clipper's Moonraker API middleware.
That is wild.
It really is. What is fascinating here is the AI completely escapes its semantic vacuum.
Right, so it transitions from just a text generator sitting on a server into an active physical orchestrator in the real world.
Exactly. It dynamically rewrites the printer's mechanical DNA in seconds and without recompiling any code at all.
Okay, so with this new brain connected, what does it do? Does it just start autonomously testing its physical body?
Yeah, pretty much. It systematically probes the GPIO connection pins to map its own boundaries. And it even uses trinamic stall guard sensitivities, so the motors can literally feel when they bump into an obstacle.
Like a digital sense of touch for sensorless homing.
You got it. And it gets better. It runs complex fast Fourier transform analysis on accelerometer data to mathematically cancel out mechanical ghosting vibrations.
Wait, really? So it figures out how to stop itself from shaking during fast prints entirely on its own?
Yes. And, it scales up too. In a distributed setup, like this concept of NIKI's print farm, the AI acts as a central nervous system.
Right.
It queries the Schoolman database for exact filament inventory. And if a print starts failing and turning into spaghetti, the AI uses computer vision to spot the error mid-print.
Oh, I hate when that happens.
Right. But the AI just issues an exclude object command to autonomously cancel that single ruined piece while the rest finish perfectly.
Okay, here is where it gets really interesting to me, though. If this AI has root access to everything, what stops a hallucinating AI from just overriding the thermal limits and melting the machine down?
Well, security is definitely paramount when an AI controls physical heaters. So mitigating fire hazards requires strict sandboxed environments.
Makes sense.
And a concept called progressive disclosure. The AI only gets access to the tools it exactly needs for the immediate task.
So it can't just access the safety protocols willy-nilly.
Exactly. If it determines a change is needed for the Clipper thermal runaway protections, it hits a hard human confirmation gate.
Like an admin PIN.
Right. It needs an admin PIN from a physical person before altering those safety limits.
Wow. Okay, so for you listening, this is really the ultimate aha moment. Hardware is no longer just a static thing.
No. It is becoming fully software-defined, self-calibrating, and self-healing.
Which leaves you with this to chew on. If an AI agent can autonomously reverse engineer and run a 3D printer from scratch, what happens when we plug that same AI into the autonomous factories that manufacture the printers themselves?